Hi, welcome. I'm trying to learn biochemistry. Today, solutions, colloids, and suspensions. And after we've done that, we're gonna do standing yoga. And if you participate in the standing yoga, then it's video on this. And this is part 6 of the solutions, colloids, and suspensions. We made a video about what mixtures are. Mixtures are that two or more different things are mixed together so that they are physically blended together, but they did not form new chemical bonds. Combination of elements or compounds that are physically blended together but not bound by chemical bonds. We had the solutions done, and solutions, these are, there is the solute, salt for example, and the solvent, water, dissolved, and that forms sweat. It is evenly dispersed in the solute, the sweat is the salt in the sweat, and it is not settling down over time, and it is transparent. You can watch through it, you can look through it. They are colloids. Colloids, they are basically the particles in it are bigger. What do you say? Size of the particles are bigger, and they are not transparent. They are usually opaque or translucent. Translucent, opaque. For example, milk. There are milk proteins in it, and therefore they are colloids. But the milk is also a solution because of the lactose in it. The other thing was calcium salts. Okay. And now the suspensions, I'm talking now about blood and a bit. For example, blood is a suspension, and if blood is drawn fresh, it is reddish. If it stays for a few days in the tube, it will settle down. And at the top will be the liquid part, the plasma. I think it's yellow, it's not really here, but I think it's yellow. And now that is now a suspension because over time it settles down. The plasma itself is also a solution because there are ions in it. Is both a solution of ions and other small solutes, and a colloid because of the plasma proteins. So because of some ions in it, even dispersed, the plasma part of the blood is a solution, and a colloid because of the blood proteins, of the plasma proteins, but it is a suspension because over time the things have settled down, the blood cells have settled down to the ground. Now we're going to do a video about all three, and we did a video about all these three and the mixture part. Now we're going to do a video about all these three and say what these three represent. So I'm going to start the camera again. A second. And let's try it. Solutions, colloids, and suspensions. They are all type of mixtures, but they are a little different. There are suspensions, there are solutions. First, solutions, and there are particles in it, and they are evenly dispersed, and they are also transparent. You can look through them, and they don't settle down over time. So evenly dispersed stays like ever. Sweat, for example. There is the solute, salt, dissolved in the solvent, the water, and it is evenly dispersed, the salt, and it does not settle down, and you can look through it. Then there is something else, the colloids. For example, milk. And basically the main difference is the size of the particles. The milk proteins are too big, it is translucent, opaque, are colloids usually. You cannot see it from milk. Milk is a solution and a colloid because in the milk there's also lactose and calcium salts, and therefore it is a solution because there is the lactose in it, for example, the milk sugar, the lactose, but there is also the milk proteins in it, and therefore it is a colloid because you cannot look through it. And then there are the suspensions, for example, blood. And blood, if it is drawn freshly, then it is reddish overall, but over time it will settle down, and at the top there will be the liquid part of the plasma. Now the plasma is a solution and a colloid because there are ions in it and other things. The solution completely dispersed, visible fluid, but there is also a colloid, the plasma part at the top of the whole blood, because of plasma proteins. Now, and the blood cells, they have settled down, and therefore it is a suspension because they settle down. So solutions evenly dispersed, visible fluid, stays like ever for it, and colloids you can't look through it because of milk proteins, for example, in milk, and blood is suspension. Over time it will settle down. And that is according to Gerard Tatoga and Sandra Grabowski, Principles of Anatomy and Physiology, book, page 38, but this is no medical advice. I'm going to stop the camera. And we have a little time left to look what is here written about the concentration of a solution, how it is expressed. So, the concentration of a solution may be expressed in several ways. Two common ways are by percent, which gives the relative mass of a solute found in a given volume of solution, and also in units, in moles per liter, which relates to the total number of molecules in a given volume of solution. A mole is the amount, in grams, of any substance that has a mass equal to the combined atomic mass of all its atoms. For example, 1 mole of the element chlorine, it has the atomic mass of 35.45, is 35.45 grams, and 1 mole of the salt sodium chloride is 58.44. Because, and Na, that is sodium, shortened. In the last part I said natrium. It is because in multiple language it is natrium, and for it is, I think, in Latin natrium, and that is why the symbol of natrium of sodium is Na. And it has in many languages the name natrium, but it is sodium in English. So 22.99 is the gram amount of sodium, of Na, sodium, and then the 35 for the chloride, and together that whole thing has now a mole of 58.44 gram. Just as a dozen always means 12 of something, a mole of anything has the same number of particles, and these are either 6.023 or 6023 times 10 to the 23rd. This huge number is called Avogadro's number. Thus, measurements of substances that are stated in moles tell us about the numbers of atoms, ions, or molecules present. This is important when chemical reactions are occurring, because each reaction requires a set number of atoms of specific elements, and not an amount of gram of weight. Now, I don't completely figured it out. It sounds pretty complicated. It is technically very easy, but I haven't completely understood it. You basically have a fixed number of atoms that you say, like 12. That is the example with dozen, but we're taking the Avogadro's number. And we're saying 6 billion or whatever the Avogadro's number is, it's much more, of the sodium particles weigh so much. So the Avogadro's is 6, I'm going to say now 6 billion, it is more than 6 billion. The 6 billion of sodium weighs 22.99 gram. And of chloride, if you have 1 mole, it weighs 35.45 gram. So mole says that amount of atoms, molecules, or whatever of that substance is 1 mole. So 1 mole of gold is the same number of atoms as 1 mole of iron. But it weighs differently much. But it has the same number of atoms. And so by saying it is possible to say now there's so much sodium in the water. By saying it in percentage, there are, what did we have last time? 0.5, what was it? Of salt in, or sodium in something. But you can also say there is 1 mole in it. And 1 mole would mean there are 6023 to the 10th to the 23rd of sodium atoms in it, basically. Or sodium molecules, whatever. That is it, basically. Now, am I able to save it? Not really. If I make a mistake or mix something up, I just can do it the next time when I really understood it. Can we do some other presentation to it? I don't understand the Avogadro's number, but it's the first problem. I don't know if it's 6.023 or 6023. So I cannot make a video about it, really. Okay, that means we're going to close the chapter in a later part, but it doesn't have to be necessarily in biochemistry. We will then do a video about what is a mole and how to measure a mole. So far, it is the following. 1 mole of sodium are 6023 to the 23rd of amount of sodium molecules, and 1 mole of chloride are 6023 to the 23rd of chloride atoms. Same number of atoms, but they have a different weight. Now, that was the biochemistry part. If you were here for biochemistry, you can go directly to the next part of biochemistry. If you stay here and participate in the standing yoga, then it's very honest. Lifting the feet standing together, and we're breathing in, and we're doing the eagle swings. Breathe in and lift the arms. And again, arm the arms down. In and up. Out and down. In and up. And open to the side. In and up. Down to the other side. In and up. Make an inch of space between the feet and open again to one side. In and up. And out and sink down. In and up. Open to the other side. In and up. And out and down. In and up. And out, lean onto the knees. Breathe again in. And out, make a head with the back. In into the middle. Out and belly with the back. In into the middle. Out the belly. Ahead. In into the middle. Out the belly. In into the middle. And out, come with the round back up and make it the top and backwards, shoulder, shoulder. Please lift the arms up. And open again to the side. In and up. Out the arms over the sides down. Breathe in, come halfway up. High up and out and up again. Breathe in, reach high. Out again down. In and up. Out the arms over the sides down. In, come halfway up. High up and out and up. Breathe in, come up into tiptoes. And breathe out, sink down into the chair. This can go onto the knees. In and up. Out and down. In and up. Out the arms over the sides down, feet together. Breathe in, bend the right leg. And breathe out and stretch the left leg. In into the middle. Out and stretch the right leg. In into the middle. Out, stretch the left leg. In into the middle. Out, both legs straight. Breathe in, lift the right hand up to the sky. Breathe out, bend the left knee and look over the right shoulder to the right hand. Inhale down. Out and down. In, left hand up. And out, bend the right knee and look over the left shoulder to the left hand. Inhale down. Out and down. And now make a hand with wide space between your feet. Shift the weight to the heels and breathe in and cut out. And out and up again. In and down. Out and up. Take hold on the elbows and gentle rock from side to side. Hands again down, feet together. Breathe in, come halfway up with a straight back. Out and down. In, halfway up. Out and down. Breathe in, come up again. Out the hands down. Bring the hands together, the elbows together. Breathe in, reach high. Out and down. In and up. Out and down. Elbows back. And out and front. Breathe again in. Out and front. Now we stretch of Venus. Legs are standing shoulder width apart. Intertwine the fingers behind the back. Bring them over to one side. Tall up, shoulders back. Breathe in. And out, turn the head slowly over to one side. Chin down onto the clavicle. Pull the arm and the shoulder. Breathe in, lift the gaze. And turn the head over to the other side. Hands over to the other side. Breathe in. Out, chin down onto the clavicle. Pull the arm and the shoulder down. Breathe in, lift the gaze and turn back into the middle. Have the feet standing together. Breathe in, lift the arms up. And breathe out, lean back, draw the shoulder blades together. In and up again. Out and back. In and up. Over, cross the arms, intertwine the fingers, reach high. Breathe out, reach in front of the back. In and up. Over, cross the other way around. Breathe in, reach high. And out, reach in front of the back. In and up. Out, lean with long arms back. In and up. Out and back. In and up. And out the arms down. Breathe in the arms again up. Out and down. And in and up. Bring the hands to touch and lower the hands down to heart center. Breathe out. And that was the second yoga. Thank you very much, and at the next time.